Okay, so question number 6. Aside from hydrogen atoms, what else is needed to form hydrogen bonds? So hydrogen, I think they mean like hydrogen bonding, maybe. So when you have hydrogen bonding, we also need a hydrogen atom that is attached to an electronegative atom. So some examples would be like nitrogen, oxygen, or fluorine. So the reason we need an electronegative atom is because we need to create dipole moments in our molecule in order to have hydrogen bonding take place. So I'll just have a common example showing the water molecule. So you'll see that 2 hydrogens are attached to oxygen. Obviously, we know water is H2O. But also, oxygen is much more electronegative than hydrogen is. So it will pull the electrons. It has an uneven share of electrons in the bonds with hydrogen. So the side that contains the oxygen has a partially negative charge, and then the side of water that has the hydrogens will have a partially positive charge. So we can show that this water molecule has an overall dipole moment in the direction towards the oxygen. So what happens with hydrogen bonding is that when we have a second water molecule, which I'll draw down here, it also has a partially negative side and a partially positive side. And hydrogen bonding is actually the attractive force that these partially charged atoms feel. So that partially positive charge on the hydrogen will be attracted to the partially negative charge of oxygen on a different water molecule. So then you can kind of show how all of these water molecules can be kept together because of this thing called hydrogen bonding. Yeah, so you can see that it is this intermolecular force, and that is why we need both hydrogen and also this electronegative atom, because if we had, let's say, a methane molecule, this is a nonpolar molecule, so that same dipole moment that happens in the water won't take place in a methane. Let me just put like an X in between. So let's see what the junior tutor said. Hydrogen bonding is a dipole-dipole interaction of molecules to a hydrogen atom. The bonding results from the attractive force of hydrogen, which is covalently bonded to a very electromagnetic atom, such as nitrogen, oxygen, or fluorine, and an electronegative atom. Oh, yep. And then for molecules containing hydrogen atom bonded to nitrogen, oxygen, or fluorine, the large difference in electronegativity between the atoms leads to a highly polar covalent bond. Therefore, aside from hydrogen atoms, polar covalent bonding is also essential in forming hydrogen bonds. Yep, so this solution is correct.